All right, so in this presentation, we're obviously going to be looking at Chapter 7. Chapter 7 deals with truth tables. This is the most general and most systematic and a very reliable, perfectly reliable method for determining whether an argument is deductively valid or deductively invalid. And we've seen a few other methods of doing this before. So there was the famous forms method, you might remember, from Chapter 1, where you figure out what the form of the argument is, that is, what the pattern or the structure of the argument, and if it matches one of the argument forms that we know is always deductively valid, then you know that your argument is deductively valid. Or if it matches one of the forms, the argument forms that we know is deductively invalid, then you know that the argument you've got is deductively invalid. We also looked at like the Venn diagram method for determining deductive validity or invalidity of categorical syllogisms, which were this special kind of argument. And those are all fine, right? The famous forms method and the Venn diagram method and whatever other methods that you've seen in the past, those are all fine. But this is the most general and systematic way of determining the deductive validity or invalidity of arguments, and it applies to any kind of argument. It applies to arguments whether they match any kind of famous or even just not famous, but just a basic argument form or not. It could be some really crazy complex argument, it doesn't matter. It could be involving categorical statements or not, doesn't matter. The truth table method will work every time. The only problem is that it's a somewhat complicated process to get there, right? To get all the way to the point of actually properly constructing good truth tables to represent an argument. There's a lot of steps to get there. Hang with me here. But once you get through it and you get used to it, you get comfortable doing this, and you get some practice, then it turns out it's pretty straightforward. And like I said, it's very systematic and completely reliable method for determining deductive validity or invalidity of arguments. And so just as a preview, this is, I'm not expecting you to already sort of understand exactly what you're about to see, but just so you see where we're aiming, this is what a truth table looks like for a relatively simple argument. So we'll see how we get there. But we need to sort of set things up, right? Set the stage before we get to the point of where we can actually put together a full truth table like this. Okay, so first definition here, we've seen this a bunch of times, falling back on this sort of rough and ready definition of a statement. So it's just a simple declarative sentence that can be evaluated as true or false. And of course, when we're dealing with arguments, only arguments can be deductively valid or invalid. So that term deductively valid, it only applies to arguments. And arguments, you might recall, are things that have a set of statements, premises, to support a specific conclusion, which is also a statement. So arguments are built from statements. So if we don't even have statements to begin with, then we can't evaluate it as being deductively valid or invalid because it's not an argument. So we got to start with statements. Now here's the term that we haven't seen before, operators. Although we have seen the operators before, we just haven't called them operators before. So just the term not, right? So a statement might be, it is raining. Well, if we then want to say it is not raining, well, the not there technically is an operator that's been added into this basic statement. So here's the other operators, the other standard operators. And, that's an operator. So it can connect, it can conjoin two statements. Or is an operator. If then is an operator. And here's one we haven't really seen much of, but it is one of the standard operators, if and only if. Okay, an atomic statement is just a very simple statement and it doesn't have any operators at all, right? So if there's an operator in there that's doing the work of an operator, then it's not an atomic statement. So I already mentioned some examples, but so here are some examples. It is raining, roses are red, Bob is sleeping. Right? Those are very simple atomic statements because there's no operators there. And notice that they're all affirmative, that is, they're all positive statements saying that something is the case, right? Because if you say it's not the case, well, not is an operator. And so if it's got the not in there doing the work of an operator, then it can't be an atomic statement, because atomic statements are statements that do not have any operators. Now, on the other hand, are compound statements. So a compound statement is, of course, a statement, but it's one that's got an operator, along with at least one atomic statement. So let's look at some examples of that one. Here's examples using our basic example, our basic atomic example, but then adding in all the different kinds of operators. So it is not raining. So the not operator, you could throw in the and operator. It is raining and the ground is wet. It is raining or it is not raining, right? So the or is the operator there. Then we've got one with the if-then operator. If it is raining, then the ground is wet. And the if and only if. It is raining if and only if water is falling from the clouds. Okay, so those are all like fairly straightforward compound statements because they've got an operator doing some work there. Okay, so moving along, let's start with just this very simple example argument, something we've seen before. And so we'll sort of begin the process that we need to go through in order to set up a truth table for an argument like this. And you might notice, if you remember some of the famous forms back in chapter 1, this argument has the modus ponens argument form. And you might remember that modus ponens is a deductively valid argument form. So, you know, sort of giving it away a little bit here, that this argument is deductively valid before we even bother constructing a truth table for it. But let's go through the process anyway. So the first thing that you need to do, notice, by the way, I should mention this, that you know, we've got two premises and a conclusion here, but what we've got really are just two atomic statements that are involved in this argument. It is raining and the ground is wet are the two atomic statements involved in this argument. So the first thing that we want to do is symbolize the atomic statement. So we just pick a capital letter to symbolize an atomic statement, a different capital letter for each atomic statement that's involved in the argument. In this case, we just have two atomic statements, so we just need two letters. And then replace the atomic statements with their associated letter. So then our argument looks like this over here on the right. If R, then W, that is, if it's raining, then the ground is wet. And then the second premise is just R, right? It is raining. So therefore W, that is, the ground is wet. Then we need to symbolize the operators that are involved. And there's really only one operator that's at work in this argument, the if-then operator. But you'll need to be able to symbolize all of them. So here are the standard symbols that are used for the different operators. Unfortunately, even though I'm calling them standard symbols here, they are not standardized across all of logic and all of philosophy. You get somewhat different symbols being used in different textbooks and by different instructors or professors involved with doing these things. But I'm going to stick with the symbols that are in our textbook just to keep it, you know, easy, relatively easy anyway. So the not operator, the term that we use for that, and this is standard across everybody, is we call that the negation. But the symbol that we're going to use here, this is not unfortunately standardized among like all around the world, but this is the symbol that's used in our textbook. The tilde, this little squiggly line, that means the negation operator. And is the conjunction operator, and in our book that's symbolized just by this simple dot. So that means and. It means conjunction, or that's the disjunction operator, and that's symbolized by a V. I don't know why they decided on a V, but that's what we've got, so we got to stick with it. The if-then operator, that's called the conditional, and that's symbolized, simply enough, as just an arrow. And the if and only if, it's called the biconditional, and so that's an arrow going both directions. Okay, so then if we use, it was the if-then, the conditional operator that was at work in our example argument. So now if we replace, remember we were up here, we had already replaced the atomic statements with their symbols. Then if we replace that operator, the conditional operator at work in premise 1, then we get this, right? So if R, then W is what we got for the first premise. Second premise is just R, so therefore W. If it's raining, then the ground is wet. It is raining, therefore the ground is wet. Okay, so let's look at some other examples of other operators and how they work, because things can get a little complicated pretty quickly. You know, we can get some pretty complicated compound sentences going. So let's just the basic negation operator. So let's say somebody says, Chris is not a Buddhist. Well, the atomic statement there is Chris is a Buddhist, right? Because an atomic statement is always the affirmative. Then if we want to turn it into the negative, which is what our original statement was really trying to say, Chris is not a Buddhist, then we put the negation in front of that atomic statement, all right? So it is not the case that Chris is a Buddhist, is sort of how we could read this to sort of capture the logical meaning. All right, more complicated one. So Chris is not a Buddhist or a Hindu. So what is this person really trying to say? There's these two religions, and Chris is not a member of either religion, right? He's not a Buddhist, and he's not a Hindu, right? So Chris is not a Buddhist or a Hindu. So the atomic statements, Chris is a Buddhist, and the other atomic statement, Chris is a Hindu. So just represent those by B and H. So there's actually a couple different ways of representing this using the symbols. And notice I've got parentheses here. That's going to be very important when we've got these somewhat more complicated compound sentences. And it works a little bit like mathematical equations. So if you remember back to your math classes, whatever's in parentheses, you do that first. And then you apply whatever's outside the parentheses, you apply that to what's inside the parentheses. So that's what we've got going on here. Inside the parentheses, we have Chris is a Buddhist or Chris is a Hindu. And then the negation is on the outside, so it applies to that whole thing. It applies to everything that's inside. So it's not the case that Chris is a Buddhist or Chris is a Hindu. Notice if we leave the parentheses out, that changes things dramatically. If we leave them out, but everything else is the same, leave out the parentheses, but everything else is the same, we get this, which is, if we were to translate this back into English, it would be, it's not the case that Chris is a Buddhist or Chris is a Hindu. And that's not capturing the meaning of the original statement at all, right? The original statement says he's not both. But this one that says Chris is not a Buddhist or Chris is a Hindu, that leaves open the possibility that Chris is a Hindu. And that's not what the original statement was trying to do. It was trying to close off both possibilities. There is an alternative way of accurately representing this compound statement that we started with, and that's over here. So negate both of them and put the conjunction operator, the and between them. So this would then say, it's not the case that Chris is a Buddhist, and it's not the case that Chris is a Hindu. And although that's somewhat of a rephrasing of our original statement, it still captures the logical meaning, right? He's not either one. He's not a member of either religion. That's what's trying to be expressed here. Okay, moving on to some other examples. So here's one that's involving two operators again. It's involving the conditional and the negation. So what's this saying? It's not true that if you get good grades, you'll get a good job. Right, so what's going on here? So suppose somebody says, well, if I get good grades, I get an A in every class, right? So if I get good grades, I'll get a good job. Or they say, if you get good grades, you will get a good job. And then somebody else comes in and says, wait a minute, that's not true. That conditional is not true. It's just not the case that if you get good grades, you'll get a good job. So how would we symbolize that? Well, first, of course, we have to symbolize the individual atomic statements. And so the atomic statements are, you get good grades, and then the other atomic statement is, you will get a good job. And then we have a conditional operating on those two atomic statements. So if you get good grades, then you will get a good job. So that's what we've got the arrow for. And then we want to put those in parentheses because the negation is applying to that conditional. Right? That's what the negation is applying to. The negation itself is not applying to either of the atomic statements alone, it's applying to the conditional. So that's why we have to put it on the outside of the parentheses. So it's not the case that if you get good grades, you'll get a good job. Again, just to sort of drive home the point, if we leave out the parentheses, that changes the meaning dramatically. So if we leave out the parentheses, we get this, which says, if it's not the case that you get good grades, then you will get a good job. And that's very different, right? That's a weird thing to say, that like, if you don't get good grades, then you will get a good job. Well, then that would seem to be a motivation to not get good grades. And that's not what that statement is saying. And so we have to be very careful about how we use these parentheses. Okay, here's another one, even more complicated. So we actually have, notice, two different conditionals connected by this conjunction. And so the conjunction is applied to two separate conditionals. So if you get good grades, you'll get a good job. And if you work hard, you'll get promoted. So now we've got somebody remaking this claim that if you get good grades, you'll get a good job. We don't have anybody trying to negate that conditional. Right? So if you get good grades, you'll get a good job. And once you're in that job, if you work hard, you will get promoted. So now we've actually got 4 separate atomic statements involved here. And 2 different conditionals. The first conditional, if you get good grades, then you'll get a good job. Other conditional, if you work hard, then you'll get promoted. And then we've got the conjunction combining those two. And notice that, again, it's very important that we have these parentheses here to make it clear what the conjunction, the and operator, is actually working on. It's conjoining the 2 conditionals. It's not conjoining 2 atomic statements at all. It's conjoining the 2 conditional statements. Okay, moving on. Notice this is an important point, that the default assumption for the or operator, that is the disjunction, is that it's, as they call it, inclusive. So A or B, what that means is A or B or both, right? So A is true or B is true, or they're both true. That's what the or operator, the disjunction, really means. Unless somehow in the English sentence, it's making it very clear that they mean the exclusive or, right? So if the English sentence is making it clear that the intended meaning is either A or B, but not both. So for example, they could be talking about a sporting event that doesn't allow ties, like basketball typically does not allow tie games. So if A represents the statement, the Phoenix Suns won, and then B represents the statement, the Denver Nuggets won, then if they're playing a basketball game, they can't both win, and they can't both tie. And so we would say either the Suns won or the Nuggets won. And it's not the case that the Suns won and the Nuggets won. Right, so either A or B, and it's not the case that A and B. And if we wanted to express the thought like neither of them, right? Neither of them is true. Well, there's 2 standard ways of doing that. We could say it's not the case that A or B, right? So it's not the case that the Suns won or the Nuggets won, because maybe the game got canceled, right? So neither one won the game because the game just didn't happen or got canceled halfway through. It wasn't allowed to finish. An alternative way of saying expressing the same idea would be this way. So it's not the case that A, and it's not the case that B. Right? So it's not the case that Phoenix won, and it's not the case that Denver won. Okay. Another point is biconditional, the if and only if. That is ultimately the same as 2 conditionals. So if we want to say A, if and only B, that's the same as saying if A, then B, and if B, then A. That could become important later on when you're trying to symbolize an argument. All right. So let's look at now a somewhat complicated paragraph and see how we would go about symbolizing this. So I'll just read this out. If Dostoevsky was right, then everything is permissible if God does not exist. But it is not true that if God does not exist, then everything is permissible. Therefore, Dostoevsky was wrong. So that's a weirdly constructed paragraph, isn't it? It's a little bit hard, perhaps, to sort of understand what's trying to be expressed here. So Dostoevsky was of the opinion that morality requires the existence of God, right? If there's no such thing as God, according to Dostoevsky, then there's no such thing as morality. So he would say that if God doesn't exist, then everything is permissible, right? Anything goes, and there's no good, there's no bad, there's no right, there's no wrong, anything goes. So that's what's being expressed here. If Dostoevsky was right, then everything is permissible if God does not exist. But it's standard opinion in philosophy, especially in the area of ethics, that morality does not require God. Right? So God could exist or not exist, and their morality is still real. It still is an existent thing. So that's what the second premise is saying. That's what the second compound statement is saying here. But it's just not true that if God does not exist, then everything is permissible. So most philosophers would think that Dostoevsky is wrong on this point. So that just kind of gives you maybe a better sense of what this paragraph is trying to say. All right, so what are the atomic statements here? There's just three, even though we've got a kind of a complex thing going on here, there's just three atomic statements. So here they are and how we could symbolize them. And notice also that even though this is a somewhat complicated paragraph going on here, ultimately this is the modus tollens argument form is what's going on. You maybe noticed that if you were remembering the modus tollens argument form from chapter 1. And it turns out that the modus tollens argument form is deductively valid. But in any case, how would we symbolize this whole mess? It would look something like this, right? So we've got our atomic statements symbolized by our capital letters. And then here's the first premise. If Dostoevsky was right, so if D, then what, right? Then another conditional, right? Then this other conditional is the case. And what is that other conditional? The other conditional says that if God does not exist, then everything is permissible. And so if Dostoevsky is right, then if it's not the case that God exists, then everything is permissible. And the second premise negates that conditional, right? It negates this. So the second premise says it's not the case that if it's not the case that God exists, then everything is permissible. So therefore, it's not the case that Dostoevsky was right. In other words, he was wrong. In fact, I rephrase the paragraph here. This paragraph is straight from the textbook. But if we rephrase it, maybe it's even a little more straightforward exactly how these symbols, how this symbolization matches the argument. All right, so if Dostoevsky was right, then if God does not exist, then everything is permissible. But it's not true that if God does not exist, then everything is permissible. Therefore, it's not the case that Dostoevsky was right. All right, so I'm going to end this one here, and then we'll pick up with sort of going further along in the process of how to build up truth tables. So tune in next time.